Good morning, children. Welcome to school. This is going to be a slightly different video from the ones that I've posted before because it is actually a mixed review of problems that deal with concepts or ideas that we have built throughout this week. So with that being said, let's jump right into the first problem. My purpose of the video is to sort of give you an insight and a way of how I think about the problem in order for you to understand the concept a little better. Okay, so first problem. Grisham is considering three situations below. The first situation is about a sunflower that grows at a rate of 3.5 centimeters per day. Second situation deals with the value of a car depreciating at a rate of 15% per year after it is purchased. And the third situation is the amount of bacteria in a culture triples every 2 days during an experiment. Which of the following statements describes a situation with equal difference over an equal interval? Okay, now this phrase right here, equal difference over an equal interval, just refers to the idea of a constant rate of change. So let me just write constant rate of change next to that phrase, just to get rid of that wordiness and just write something that we're familiar with. Constant rate of change just means slope. Okay, if you want to use another way of expressing that. And if we're talking about slope, then we're talking about a line. So mx plus b. Okay, so that's what they're looking at. They're looking for. They're looking for a situation that can be best modeled by a line. Okay, now the first one says that a sunflower grows at a rate of 3.5 centimeters per day. Okay, per just means that you're multiplying by the number of days. All right, so let's see. Let's say that the height of the sunflower is h, and the height depends on the number of days. So we'll call it a function h of d. And initially every flower has some height. So let's call it h1, okay? Plus, because we need to add the height that is growing every day. So that says that it's growing at 3.5 per day. Okay, we do not know at which day they want us to find the height of the plant. So we're just going to multiply by the variable d. Okay, now if you look at this line or at this function, it looks very similar to our original parent function for the line, right? We have some sort of initial value, okay? And we also have a variable, okay? In this case, our variable is going to be x, but for this one, it's going to be d, okay? And we also have a slope, okay? So the slope is going to be 3.5. We could read the other two situations and dissect them further, but for now we know that the one that can be best described by a linear model is 1. So, oops. Okay, that is going to be 1. Alright. I guess one of the other things I can mention is that situation 2 deals with depreciation, and usually depreciation can be best modeled by a exponential decay. Okay, so I'm just going to go ahead and make that comment, but expect another video that basically explains how depreciation works and how it can be best modeled. For now, I want you to have this in mind, right? Let's call it V, the value of the car per year, can be best modeled by the initial value, so let's call it V0, and 1 minus, what is the rate of depreciation? 15, so 0.15 times the years. Okay, to the years. The years is being used as an exponent. The next one talks about basically a population of bacteria that triples, right? So when I see the word triple, that means an exponential growth, right? So initially you start with some population for the bacteria, initial population, and it triples every year. So it's gonna go like that. Okay, it's an exponential growth. So the only one that deals with a linear model is going to be situation number 1. Okay, let's go ahead and jump to the next one. This next problem is actually very, very simple. So don't worry if the first one was highly wordy, just kind of complicated, okay? This one deals with rational or irrational numbers. Now we know that an irrational number is one that cannot turn to a fraction, cannot be written as a fraction. Okay, and obviously a rational number can be a fraction. So we're looking for the one that is irrational. Now this one right here deals with fractions already, right? So this one is going to be a rational number. Okay. Oops. Okay. Now the next one, answer this one right here, 2. Okay. That one is 1/2, so I have a fraction, but then I have the square root of 2. And the square root of 2 is one of those funny numbers that is irrational already. Okay, so I am adding a rational number, which is the fraction 1/2, plus an irrational number. That already there is just some funny business because if you type that into your calculator, you're gonna get an irrational number. Okay, so let's go ahead and put a star right here. Okay, because that is adding a rational plus an irrational. Okay, the next one is the square root of 5, which is irrational, but I'm multiplying the square root of 5 times the square root of 5. If you type this into your calculator, you're going to get 5. Okay, now 5 is a whole number, and a whole number can be expressed as 5 over 1 in this case, and that is a fraction. A whole number can also be expressed as a fraction, so we already know that 1 is not irrational. This one is not irrational, and let's check answer choice number 4, or situation 4, in which I have 3 times the square root of 49. The square root of 49 is actually the number 7. So 3 times 7 is going to give me 21. And 21 is a whole number which I can express as 21 over 1 if you want to write it as a fraction. So these 3 are not irrational expressions. Okay, the only one that is irrational is situation number 2. Okay, now I'm going to write a statement that basically summarizes what I just said. If you add an irrational number to a rational number, the result is irrational. Okay, so just go ahead and box that sentence because it is one of those conclusions that that you'll reach every time you add a rational plus an irrational. All right, so next and last problem. Okay, so this is a wordy problem. It talks about a real good cinema that is conducting a mathematical study. In its theater, there are 200 seats. There's adult tickets that cost $12.50 and child tickets that cost $6.25. The cinema's goal is to sell at least $1,500 worth of tickets for the theater. Write a system of inequalities that can be used to find the possible combinations of adult tickets X and child tickets Y that would satisfy the cinema's goal. The next part of the problem talks about graphing, but we obviously do not have a grid to plot the system of inequalities, so we're just going to go ahead and ignore this next section. In your Google Classroom assignment, you are not required to graph the system of inequalities. So let's go ahead and write my two items. Now they said that X was going to be designated for adult tickets, okay, and Y was going to be designated for child tickets, okay. Alright, so let's go ahead and write two lines, one that deals with quantity and one that deals with price or money. Okay, so the first thing is I want to highlight this sentence right here that says there are 200 seats. Okay, so that means that if I add my adult tickets plus my child tickets, I cannot sell more than 200 seats because there are only 200 seats. So this addition has to be less than the space that is in the theater. Okay. Next thing I want to write is something, let me just write in parentheses that this line deals with quantity. Okay. And the other line is obviously going to deal with money slash price. Okay. So I'm gonna have to multiply that 1250 because that is the price of the adult tickets times the number of adult tickets plus 625 y, right? Because that is the price for the child tickets. And how much are they trying to sell? At least $1,500. So if it's at least, that means you have to sell that or more. So 1,500. Okay. Now this is all you need to answer the question on the assignment, right? The next thing you are required to do is to graph it, but like I said, there is no grid provided in the assignment, and I also don't have a grid here. So we're gonna go ahead and stop at this stage. This is the answer to the problem. And hopefully this video wasn't too complicated. My intention is to give you a better understanding of some of the mathematics that you are required to know in order to solve these problems. So until next time, and hopefully this reaches you before the deadline.